Charge is distributed within a sphere of radius capital R with volume charge density rho r a by r square into e power minus 2r by a, where capital A and small a are constants. If Q is the total charge of this charge distribution, the radius r is given by. So in this question, a sphere is given, its radius is capital R. Okay. The volume charge density of that sphere is given by as a function of r. So which means whenever the radius changes within that sphere, whenever the change in radius is there, the charge density also changes. Okay, you can take this sphere as like this. So this is the recovered sphere. At the center, radius value is 0. So if you move outwards, its radius increases up to r. Okay. At the center, radius value is 0. At the edge of the sphere, at the outermost side, its radius will be capital R. So the r changes from the center to the outward. Okay. So along this r value, density is also changes. If the density changes, the charge value contained in the sphere is also changed. Okay, so we can write this in differential form. So general formula for this volume charge density is rho equal to Q divided by V, which means the amount of charge contained in a given volume. So in this case, the density changes with the function of R. For a given R, the Q value will change. At the same time, V values also will change. So we can write this as in differential form. So rho is the function of R is given equal to dq divided by dv. Okay, so I am just rearranging this equation. So I will get dq equal to rho r into dv. So first I am going to find the value of q from this equation. So I am just integrating it. dq equal to rho times r into dv. So we know that the volume of sphere is, what is volume of sphere? Volume of sphere V is equal to 4 by 3 pi r cube. So if you check the question, the density is given as the function of radius. So we cannot integrate this directly with the variable v. Okay, so we have to convert this dv in terms of dr. So I am taking this volume of sphere formula. So I am going to convert the dv into dr using this formula. So I am just differentiating this with respect to r. So we will get 4 by 3 pi into 3r square. This 4 by 3 pi is a constant one, and the differentiation of r3 is 3r square. Okay, now you can cancel these 3's. So you will get dv equal to 4 pi r square into dr. So this is v and this one is r. So let me substitute this value. So the r value changes from 0 to r and q changes from 0 to q. At the center there will be no charge. When the r is 0, the volume of the sphere is 0, then the q will be not there. So at the maximum, at the outer edge, the value of r is r and the net charge is capital Q. That is given in the question. Okay, the Q is a total charge distribution at the radius r. Okay, so we have to take at the outer edge of the sphere, the entire charge enclosed in it is capital Q. Okay, now substitute the value of rho in this. A by r square e power minus 2r by a. Okay, into, instead of this dv, I can replace this 4 pi r square into dr. 4 by r square into dr. Okay, now you can cancel these two, r square and r square. Okay, now integration of dq with respect to q will be q. If you substitute the upper limit, you will get the q, and lower limit will be 0. In this case, you can take the 4a pi, these terms are constant. Okay, this is small a. You can take this out, you will get 4 pi and a are constant. You can take that out and you will be left with e power minus 2r by a into dr. Okay, now try to complete within the space. So integration of and 4 pi a, integration of e power x is e power x, but in this case we have the one more variable then. So general formula is e power ax dx is equal to e power ax divided by a, okay, plus c. Here the limit is not there, so I am using this formula here. Instead of a I have the minus 2 by a, okay, I am just using this formula here. So you will get e power minus 2r by a divided by minus 2 by a, limit is 0 to r. Okay, now you can take that outside before substituting the upper and lower limit. Okay, q equal to 4 pi a. Here it is in denominator. If you take that to numerator, it goes into the form of reciprocal, so you will get minus a by 2 into e power minus, upper limit is 2r a and lower limit is e power minus 2 into 0 by a. Now we can cancel these two 2's. You will get minus 2 pi capital A small a, on this side you have q, and this side you will have minus 2 r by small a, and 0 into anything is 0, 0 by anything is also 0. You will get e power 0. Okay, now you can take this to this side. You will get q divided by minus 2 pi aa. Okay, q divided by minus 2 pi aa is equal to e power minus 2r by a minus 1. So our goal is to find the radius r. So I have to keep the r term here, and I am going to take the remaining terms to the left side. Okay, so I am taking this minus 1 to this side. That will become 1 plus, sorry, 1 minus q divided by 2 pi aa equal to e power minus 2r by a. I'm going to take the reciprocal on both sides. This negative term will be positive. Okay, I will get 1 divided by 1 minus q divided by 2 pi aa equal to e power 2r by a. Next I am going to take log on both sides. Log of 1 divided by 1 minus q by a equal to 2r by a. Okay, after this you can take the 2 by a to this side. Okay, you will get, so I am writing here, and 2 by a become a by 2. Okay, a by 2 into log of 1 divided by 1 minus q divided by 2 pi a. So that's the required radius. So this is in option D. Okay.